Welcome to CS179 Networking 1. I am your instructor, Robert McMillen. We are now in Module 6. And in Module 6, we're going to be talking about TCP/IP applications. So our outline is going to be TCP and UDP, registered ports, well-known ports, dynamic ports, and various different applications that use those ports. Let's start with TCP. Of course, it is Transmission Control Protocol, and it lives at the transport layer. It is connection-oriented. If it sees any kind of failure, it will resend, and it goes when a client sends data, it sends a SYN request, and then the server sends a SYN ACK request, and then the client sends the ACK request. This is known as a three-way handshake. So that way both the client and the server have confirmed that they will send and accept this data packet, and the server knows that it's coming from this particular client. Then this information will be put into a table, and that table will show the connection and what ports they are using. When the data is no longer being sent after a certain amount of time, and that specified time is different for different operating systems, then the connection will be dropped. Talked a little bit about UDP in our last module, User Datagram Protocol. It is connectionless and it is built for speed. So it receives the packets from the sender in any order with no error checking. So of course the sender has no idea if the receiver has received the packets, but it doesn't care because speed is more important than knowing that every single packet got there and reassembled properly. So this is something that's going to show up on a lot of the different quizzes, is registered ports, the ports that we're going to be talking about in the next few slides. The first one is going to be registered ports, and these ports are registered to ICANN. That's that international organization that basically takes any kind of standards and records them and makes sure that everyone follows them in order for the internet to run properly. So these ports that are called registered ports are from 1024 to 49151. Now there's 65,000 ports of TCP and 65,000 of UDP, actually 65,535 to be exact. And if you have an application that has really taken off and everybody is using it, then you could register that particular port between 1024 and 49151, and then only you will be known to use that particular port. One port, for example, is 3389 TCP, and that's used by Microsoft for remote desktop. So nobody else can use that port because it is registered. And so there's lots of different ports that are above that 1024 that are registered. The next kind of port we're going to talk about is well-known ports. Now, well-known ports came out in the very early part of the Internet's creation. And this is not based by different manufacturers for the most part, although there are some that in this first 1024 ports where it is. Most of these are based on application types, and then any different company can use it as long as they use it for that particular application. So the range is going to be from port 0 through port 124. It can be TCP or UDP over IP, doesn't matter. And an example of this would be SMTP. So SMTP is what we use to send our email, and that is going to be port 25. So any company that creates a mail server will want to send over port 25 because that is the well-known port that makes email work. You certainly could try to send it on port 26 or some other port, but unless the receiver knows that you're going to send it on a non-well-known port, it won't know enough to accept it, so the traffic will be rejected. So that's why everybody uses port SMTP, port 25 or SMTP type traffic. Of course, there's a lot of other types of traffic as well. There's port 80 for HTTP. There's port 110 for POP3. There's port 23 for Telnet. There's port 21 for FTP. So some of these ports you're going to want to memorize because they do show up on quizzes, not just in this class, but in other classes and certifications. So you're going to want to know like the top 20 to 25 different well-known ports and what they're registered to. Let's talk about dynamic ports. Now, dynamic ports, this is a little bit on the complex side, but I will try to walk you through it. So the dynamic ports can be either TCP or UDP. They're not registered by anybody. So anybody can use it for any type of application, but you can't register them in this range of 49.152 through the very last port, which is 65.535. So you would use registered ports in the following way. Since only one person can connect to a port at a single time, then dynamic ports are used extensively in order to allow multiple people to all connect to the same resource. So let's say, for instance, that you go to a website, and say that website is google.com. And you connect on your internal LAN to google.com on HTTP, which uses port 80. Now let's say that your neighbor also connects to google.com, and they also are going to try to connect with HTTP, which is port 80. Problem is you both can't do that, even though it works. So why does it work? Well, you make the initial connection on port 80, but then you start sending traffic on one of these dynamic ports. It randomly assigns, your firewall and your computer work together, randomly assigning a port above the port 80 in the dynamic range of 49.152 on up. So it goes ahead and uses one of these ports in this range. So you're communicating, for instance, on 49.152, but your neighbor next to you is communicating at 49.153, even though you're both hitting the same google.com website. You don't have to obviously memorize any dynamic ports because they're dynamic. There's nothing registered here. All right, let's talk about some of the different applications that can be used with TCP/IP, and one of the most popular, of course, is HTTP, which we just talked about, Hypertext Transfer Protocol. By default, it uses TCP port 80 for communication, but you can certainly use other ports if you want to. It's just possible that the sender or receiver may not know that you're going to try to communicate on those ports unless you tell them. So they have to have a set up communication ahead of time that they're going to know it's on a different port. And let's talk about HTTPS. HTTPS is very similar, except for it runs over SSL, which is Secure Socket Layer. It uses a certificate to secure the HTTP protocol on port 443. And it's used by most websites that allow purchases online. So in this case, we've got an Amazon.com webpage up. And if you were to go make a purchase, you wouldn't check out using HTTP. You would check out using HTTPS, which it automatically sends you to. So if you go to this other place to make your purchases to check out, then you're automatically going to see a certificate. And when that certificate comes up, then it's going to either be verified or not verified. So let's go ahead and try that out. So let's go ahead and go to Amazon.com. And if we go to checkout, well, let's go ahead and add something to our cart here. So we'll add a puppy chew. Okay, so we have add to cart. All right, so you don't see any kind of secure connection up here because so far we're not in a secure situation where we need to do that. So if we go to our cart and we click on our particular item that we got because we want to check out, now when we go to actually check out, we see this HTTPS at the top. So we can click on that and then click on the connection and certificate information. And now we see it's Amazon.com, and VeriSign, which is Network Solutions, has said that this particular certificate is a valid certificate. They validated it, and it really is who we think it is. All right, let's go to the SSL part of HTTPS. That is the Secure Socket Layer. It creates a secure connection with other protocols, such as HTTP, FTP, Telnet, and it can operate on many different ports. So it uses certificates to exchange public certificates for secure communications. Basically what it does is you have on your side you have a private key, and on the other side they have a private key. What they do is they take the public key and they send it over to you after encrypting it with their private key, and only you can decrypt it with your private key. So that's how you end up in general. It's just a very simplistic way of looking at public key infrastructure. Now, you're familiar with HTTPS, because everybody has ordered stuff online at some point, but you may not be familiar with FTP that's secure. It's called SFFTP, and that uses SSL over FTP. FTP, of course, is the application that allows for large transfers of files in the most efficient manner, so across the internet. So SFTP basically uses the secure socket layer and uses that to encrypt the FTP data. Telnet also has the ability to use SSL. It's called SSH, and SSH is just basically another acronym that is what Telnet was when now that it's been encrypted, because Telnet passes everything in clear text, and SSH does everything using SSL to protect it and encrypt it. So Telnet itself, that's an interesting program. It operates by default using TCP port 23. And it basically allows a shell connection using a Telnet client to another computer or device running the Telnet server application. It's based on username permission, and it can give total control over that device. So if I use Telnet to Telnet into a device such as a firewall or a router, then it's going to allow me to take over that device and make changes. I can change its IP address, I can change its configuration, its access control lists, whatever it is that I want. And so it is a very powerful program. As long as on the other side it's running a Telnet server application, then I can use my Telnet client in order to get into it. Now, if you go and you type Telnet and you type in the IP address of the name after that, and you hit enter. In my case, I've installed the Telnet client, but if you haven't, if you get an error message saying it doesn't see the Telnet client, it says it's not an installed application, then you would go to your control panel and you would go to the programs section and you would install it. So you go to programs and features if you're on a workstation, and you go to turn Windows features on or off, because it's no longer installed by default like it used to be. And you scroll down to where it says Telnet client and you check the box. You can also be a Telnet server so people can Telnet back into you, and then you click OK, and then you will get it installed. So to summarize our Module 6, we talked about TCP and UDP, registered ports, well-known ports, dynamic ports, all of which are going to be on the quiz, HTTP, FTP, and SSL, as well as Telnet.